Great, welcome back. I'm assuming most of you were here for the morning session. Is there anybody who's joining us who wasn't at the morning session? One, two. Okay, all right. So I'll just do a quick recap with the agenda, what we've covered. Again, if you've not been to Velocity, these slides will be available later on the Velocity site. So you don't have to take copious notes, and if you miss something, you'll be able to see it. We're also hoping to post the videos at a later time. So in terms of what we've gone through so far, we've gone through a lot of concepts. We've gone through a lot of techniques and theories on how to maximize your caching strategy so you can get both performance and offload from the system. And the system includes the browser, the CDN, any proxies in between, the origin server and the origin proxy. So we went through some basic concepts in caching 101 and 201. We went through how to control these caches to make sure that whenever you need an updated version of your site, it's available to the end user. So caching is great, but it should not be at the expense of functionality, obviously. So we went through that. In the next section, this is my favorite part of the presentation, but because what we've done is we've taken a Magento application, installed it on EC2, and we've optimized the heck out of it, right? And we wanted to demonstrate all the techniques we talked about, but put it in the context of a real-world scenario. So we're going to go through that, some scenarios and guidelines in general with an e-commerce scenario, mobile API scenario, as well as a high-traffic event. So that'll sort of tie it all together. Please ask questions. It was great to make it interactive in the morning, so feel free to ask questions throughout the session. And I'll hand it over to Paul.
Sure. Grab that for me. So for our demo application, I basically set up a LAMP stack running on it's a single Amazon EC2 instance. So it's running a Magento application, and there's a Madison Island sample theme that's available for that. So it basically gives us an e-commerce store with some inventory. For the start of this, there's no content delivery network, no browser caching, no origin, no origin cache. It's basically just a vanilla install of this app. So really, this is our starting point, and you can browse to that as well. So www.advancedcaching.org. Right now you'll see it kind of post optimization, but if we take a look at kind of an initial performance snapshot, you can see here that with no content delivery network, it's obviously faster when we make that request from New York. So and this is again the impact of latency on the time it takes to make all of those requests. So the film strip on the top is from Web Page Test, California instance and a New York instance, and the one on the bottom here is using Keynote's Kite tool. So you can see over here that on the Keynote measurements, New York is faster, and London and San Francisco are both equally as slower. And then San Francisco DSL, which is a last mile measurement node, is significantly slower as well. If we try to take a look at the performance impact of latency, you can see the TCP connect time. So TCP connect time is generally a good measure of latency, and you can see that it took around 100 milliseconds for those connections to be established between the client in California to the EC2 server in Virginia. If we look at the impact of that latency, you can also see that there's a large number of small JavaScript assets here that are on this page. And these assets are really small. They're typically loaded in under 50 milliseconds on an optimized configuration with a content delivery network. But you can see here that everything is around 100 milliseconds, or a little more than 100 milliseconds. And so what you're really seeing is the impact of latency on the first byte time as well, as well as the images. So and there's some. It's not necessarily large images, but you can definitely see that there's definitely a performance cost of serving those images over the long haul rather than serving it close to the end users. If we focus on browser caching issues for now, you can see here that this particular test got an F for browser cacheability because there's no cache controller expires headers. And this is a screenshot from Web Page Test on the Performance tab. However, when I looked at the repeat view, I saw that the repeat view didn't show additional requests. So when you look at sometimes when you just look at the repeat view as your measure of success here, it could be kind of misleading. In this particular example, there was no cache control header. So with no cache control header, the amount of time that the browser that the client is going to cache it is actually not controlled or not defined. There's this concept of heuristic caching or heuristic freshness that's part of the HTTP spec, and what that basically says is if the cache control header is missing, then what it can do is estimate. So what a client can do is estimate a TTL based on the last modified date. So for example, if the object was modified 10 days ago and there's no cache control header, a browser might say, let's cache it for 10% of the time. And that's actually what Chrome and Firefox do. So in this case, we were seeing a client that was caching that content even though we didn't have a cache control header.
Just a note on that. So even though it may seem like the right thing is happening even without you intending to, it's actually masking the problem, because what if you did not want the browser to cache it and you didn't have a cache control header? That's a bad thing. What if you had just updated your resources at the origin and the last modified time was 2 minutes ago? The heuristic time to live would be much smaller. So you're not really getting, so a lot of times when you look at the repeat view, it's sometimes masking that problem. So make sure that the first thing we do is set the appropriate cache control expires headers downstream.
Any questions on this so far? Okay. So you can very easily examine the browser cacheability within some popular browsers as well. So Firefox and Chrome have an About cache and Chrome cache, where you can actually browse the cache, the items that are stored in cache. And in this case, well, you can see I've added a cache control header at this point, but you can see that you can see that it shows not only when it was last fetched and last modified, but when it actually expires within the browser. Another tool that could be very useful in terms of looking at cacheability headers and trying to understand them, as opposed to just just using your understanding of the HTTP spec, is Redbot. Redbot is a tool that was written by Mark Nottingham, who's an Akamai architect. And this, what you can do is enter a resource into Redbot, and it'll show you the response headers, and it'll actually give you some analysis of the response headers. So in this case, it's showing me that the server's clock is correct, the content length header is correct. It tells me a little bit about the cacheability. So the resource was last changed 5 days ago. All caches are allowed to store it. So any kind of intermediary cache or gateway cache is allowed to store it. The response is fresh for 6 days and 23 hours. And the response may still be served by a cache once it becomes stale. So in this case, we're allowing it to be served stale. For this resource here, the if modified since conditional requests are supported, but if none match, returned an HTTP 200 instead of a 304.
What is that mention about the iframes and the security?
I'm sorry?
That security tab.
Where do you see that?
The second one, under general.
This response prevents some browsers from rendering if it is contained within a frame on another site.
What header controls that?
That's a good question. Do you?
Oh, I see one, X-frame options, but it's,
okay.
That's only because I'm in the front row.
Oh, okay. Yeah.
Yeah.
Sorry.
We'll have to check on
It's the same
check on that.
frame option.
Okay, so that's a course
Yeah.
header?
Yeah.
So
So for this particular demo, what we did was I edited the Apache config file, and I essentially used mod expires and mod headers to set the browser cacheability based on, or the cache control headers and expires headers based on content type. So I based it for this example, I set it for 30 days, restarted Apache, and then I tested it to confirm it worked. So at this point, you can see with the curl command, or apparently you can't see if you're in the back, what I basically wound up doing was I made a curl request, and I just piped the output into a grep where I'm just looking at the response headers, and I can see cache control and expires headers. You could have also used Redbot for this as well, but I did it with curl. If I look at before and after in terms of page speed score and the web page test performance tab, you can see over here that we went from getting an F for caching static content to getting an A in caching static content, and we now see the green checkboxes here. We still don't have a CDN configured for this at this point, and that'll really be our next step. So at this point, we've got caching taken care of in the browser layer. Before we move on to the content delivery network portion, does anybody have any questions? Okay.
So next, we're going to do, we're from Akamai, so we're going to use the Akamai CDN for this test case. We'll set up a basic configuration. We're going to make it progressively more complicated or do more with it as we go through the demo. We're going to start with very basically telling the CDN what to cache, how long to cache it, and what not to cache. Right? We're going to test it via the CDN before we turn over the traffic. So there are ways where you can spoof your desktop to go to the CDN without making a DNS change. And then final switch will be the actual DNS change. So this is the only screen. We're going to show you the control portal. So we have a UI, which can also be accessed using an API, where you can send configurations to the CDN. So remember I talked about the fact that the control you have on the CDN, you can control using the HTTP headers, but you have much more fine-grained control using the CDN-specific configuration. In this case, what we have configured, this is the pseudocode, is the CDN is a shared cache. Right? So the first thing it needs to match on is whose content is this. Right? So it's for my site. It's for www.advancedcaching.org. I'm going to set the origin domain name. In this case, I want some place to go to fetch the object if it's uncacheable or if I need to revalidate it. The origin port. I'm going to set the forward host name because my EC2 instance will only respond to www.advancedcaching.org. And I'm going to explicitly set the cache key to be the host name www.advancedcaching.org. So going back to the cache key setup, what it tells the CDN is use the combination of host, the path, which is the directory and file name structure, and any query strings by default as the cache key for that particular entry. Here's where I'm going to match on what to cache on. So in this case, my logic depends on the file extension. So if the CDN gets a request for a file extension that it knows about, in this case, it's going to be a long list of JPEGs, PNG, etc. It will also be JavaScript and CSS files. It's going to set a TTL of 30 days at the CDN. It's going to set a smaller TTL downstream, right? So the TTL will be whatever is the age of that particular object in the CDN cache. So for example, if you set the TTL to be 30 days, if an end user requests for that object at day 5, the cache control header sent down by the TTL will be 25 days because the CDN is making some assumptions that it knows that that's the actual age of that object in cache, and it sets the appropriate downstream cache control headers. We're also going to tell the CDN to serve stale if unable to validate. So what that means is, let's say after 30 days there's a request. We know that the CDN needs to revalidate or check with the origin if it has changed. What if there is a network condition that prevents the CDN from connecting to the origin? I'm going to be okay with the CDN serving that stale content. So it's images, CSS. I know it's not changing that often. So let me serve it stale if needed. And then importantly, for everything else, I don't want the CDN to cache it at all. Right? So it's all my shopping carts, my personalized pages. For now, I don't want to cache it. In the future, down the road in the presentation you'll see, we'll cache some of that. So now we've set up the CDN configuration. We pushed it out. to all the CDN servers. What I'm going to do is, before I do the DNS switch, I'm going to send a request to the CDN and check for some headers. In this case, there is a CDN-specific header called xcache, which gives me some diagnostic information. So it tells me whether is this object cacheable or is considered cacheable by the CDN, and what that time to live is. And in this case, I check and I see that it's set up the way I had configured it to be. So I'm happy, and I can make the DNS change. So the DNS change, for those who haven't used the CDN, is essentially a redirection in DNS. So typically, you would have your website, www.advancedcaching.org. In this case, we had mapped it to the EC2 instance. Apologize for the text and for the size of the screen, but the slides will be available later on. So really sorry about that. But the first snapshot shows that it's mapped to EC2. And that's typically what would be the case if you don't use a CDN. If you use a CDN, then you would get the bottom right screenshot where the domain name or host name points to the CDN CNAME, canonical name. And the CDN resolves it to an IP address that's close to that end user. When the request comes to the CDN, it triggers that configuration that we talked about. So it knows where to go to fetch the content from EC2 if it needs to. And then we're going to make sure that once I've set up the CDN and I've set the DNS pointing to the CDN, that all the objects that I want to be cached is indeed being cached. So now we'll go into, you're going to do the demo?
Yeah, sure.
Can we switch to the PC, Alex?
So the private instance that we had asked you to run your tests on, we did that for two reasons. One is because I imagine a lot of people are running web page tests at this conference right now, and there's probably a better chance of you guys getting a test run if it wasn't on the public instance. The second is because I've added some code modifications to this private instance that we're going to look at. One of the modifications I added was I injected some Akamai diagnostic headers for this particular example, since we're using Akamai to serve it. Some of the other things that we did with this particular session, with this particular instance, was to take the waterfall data. So we mentioned before that some of the data that you're seeing here is going to have some Akamai diagnostic headers in the response. So you can see like the x-cache hit, and the cache key shows that it was, in this case, cacheable for 30 days. But what I wound up doing was I added all of that information to the table in web page tests, so you can now you can actually see that the resource was cached. You can see some information in terms of what was a cache hit versus a cache miss, what the IP address of the edge server was, and so forth. We mentioned before that there's the concept of using parent regions, so you can have multiple tiers in your cache hierarchy. So in this case, you can see if it was a cache miss over here, then you would see something in x-cache remote, and you'd also see an Akamai parent IP address. So that's one thing, and the other thing that so that was one way that we were able to just confirm that that this content is going through Akamai, and we were successful in onboarding it onto the CDN, and it's configured as we want it right now. And you can see that there are some third-party objects that are not using a content delivery network, or at least not using Akamai's content delivery network, and for those requests, we don't see any of the cacheability headers. Now, there are some CDNs that use x-cache. So if you're not using Akamai and you're using a CDN that has that header present in the response, you'll see something over here. So you're obviously welcome to use this. Do we want to go flip back to the slides now?
Can we go back to the Mac?
Okay. So in the case of this example here, what we just saw before was that you have the TCP hits, and then you have the kind of the gap here where this content was not served. This is third-party content. It wasn't served through our content delivery network configuration. And if we just take a look at the performance impact of just using a content delivery network in general, so now we have the request that went through the content delivery network and the request that went straight to the origin, and this was run from that same EC2 instance in California. You can see that obviously there's a faster load time and a faster page render time because the content is being accelerated. So at this point now we've configured our content delivery network. And you can see that we're now at the point where we have the browser cache control headers configured and the content delivery network configured. The next thing to do is to improve that offload further by adding a couple of additional features. And this was similar to what Rakesh mentioned before in terms of doing prefetching and using tier distribution. So what we've got here is the tier distribution is essentially using a parent and a child cache to maximize offload. So having multiple cache servers in line with the request. And then prefetching content is essentially offloading that content milliseconds before a request would be non-cacheable. And then prefreshing it is updating that cache content before the TTL expires. So you can see the advantages of the tier distribution here if we examine if we examine the flow here again, where you're serving content close to the end user. So you have the advantage here of using a content delivery network. You're minimizing origin traffic as well. And then by using this tiered distribution, what we're doing is we're sending requests to an edge server, and if that edge server is if that edge server doesn't have the content, then it goes forward to another edge server before it hits the origin. So this is especially useful for unpopular content because it's more likely to be cached at this parent tier. Then and therefore you would be able to maximize your offload and minimize the number of requests that go back to the origin. Do you want to take this up?
Sure. So yeah, question.
Doesn't the tier distribution make validation and purging really complicated because you need to sync between the tiers? If you have
Since the network is all like one single content delivery network, when you're purging everything.
It's the same.
Yeah.
Same city.
Like you can have let's say for example you simplified the map and there was a user in California that connected to a San Francisco edge server, and a Washington D.C. parent server, and then you have like an Ashburn, Virginia origin, which is what we have. So in that case, if it's not in cache in the California edge server, then it's going to go forward to the one in Washington D.C. And if it's not in cache there, it's going to go to the origin. And if you purge it, you're purging it everywhere. Now, if you have a user in, let's say, New York that's trying to make a request for a resource that is for that same resource, there's a chance that user would be going from a New York edge server to a Washington D.C. edge server and pull that item from cache rather than having a cache miss.
Yeah. So the edge servers are nothing but edge servers, the cache parent servers. They have some characteristics that are slightly different, in that they have much bigger caches because they are treated as parent servers, and they need to have a larger footprint, as Paul mentioned, of unpopular content. They also typically are chosen to be closer to the origin so that we can pull from as close to the origin, serve from as close to the user, and then we can accelerate this middle mile. Because it's our own network, we have the option of implementing certain optimizations there. Yeah.
How does this tiering affect the store and forward delay for the first hit?
It's minimal because, as I mentioned, that connection. Think of these as connections already established. So because of the fact that the cache parent is a funnel, it's going to always have connections established with the origin, and it's always going to have connections established between the child and the parent. So you're really talking about negligible delays for that first hit, and by the virtue of it being a cache parent, usually the request will be facilitated or fulfilled by the parent without having to go back to the origin. Yeah. So it's essentially adding another layer and, in fact, reducing that round trip that the edge has to make. on a cache miss.
Something that has never seen the cache before. It was just released a minute ago, and it's a megabyte. Doesn't it have to hop through one of those tiers?
Yes, it would.
Yeah.
But then it would slowly show the benefit across the board. So once it's in the parent, then all the other edges will see the benefit. But yes, absolutely. The first request will have to be populated along the way.
Another thing to be aware of is that because we're using a tier distribution framework, it doesn't necessarily mean that it's always going to go through two servers. So, for example, if I had a user in Washington, D.C. in the same data center, or if I had a user that gets routed to an edge server in Washington, D.C., and the origin is in the same data center as the Akamai edge region, it's not going to find another region to go to. It's going to automatically realize that it's close enough to the origin to just send that request directly.
Cool.
So every edge location have parents? I guess it's not. What are the numbers for distinct edge locations and distinct parent locations?
So the question is about numbers of distinct edge versus distinct parent. It's really, that's really configurable, but it's very large and smaller. It's the generic answer I can give you. But typically, the cache parents are typically a handful of regions. Each have an array of servers. So you're talking about sometimes in single digits in terms of the number of regions.
One per continent or two per continent?
Yeah, something like that. So it's in the, you can count in one hand or maximum two hands the number of cache parent regions. Each region obviously has multiple servers. And then the edge is hundreds and thousands of edge regions out there.
But the TTLs in the front and in the parts are the same or slightly different?
They would be the same. It's whatever you configure.
Yeah, it would be the same. It gets this and it's treated like any other edge server, the cache parent server. So it gets the same configuration. And you remember how I mentioned it calculates the downstream TTL. So if an edge server requests the cache parent for an object, which is already a little bit aged in the cache parent, it's going to calculate the downstream cache control headers appropriately. Any other questions? Okay, I think you should do the next.
Okay. So the next step is determining appropriate cache TTLs. So the things that you need to consider when determining your cache TTLs is how old are the objects, how long do browsers cache the objects for, so in terms of what's the cache control header, and what do we know about the publishing process? So are these assets versioned or are they or not? Are they released on any specific type of schedule? So if we know that the content sensitivity is very high, we're going to want to keep that TTL very low. Now, for versioned assets, the TTL can be very high. We mentioned that before. For non-versioned assets, the TTL should be higher than the browser TTL. And then you always need to consider what's going to happen when that content is modified. You obviously don't want to serve stale content that's going to break an application. So this particular view here is from the web page test private instance, and we should probably switch to the browser view because I can kind of zoom in better with that. Can you switch to the
PC?
Yeah, to the. Alrighty. So we looked at before where in the web page test detail view you could see the Akamai response header, the Akamai response headers in terms of cacheability. I added another header, another section up here called cache analysis. So if you click on the cache analysis tab, what you'll see here is a similar detail view, but you'll see the, and we can kind of zoom into this a little bit closer. You'll see the last modified header. So this is the date string that was sent back by the origin server in terms of when it was last modified. We can see there's a calculation here for how long it's been since it's been last modified. How long we're caching it on the Akamai edge, and how long, and then we have the cache control and expires headers, and how long until those expire. So this is a this is a pretty useful way to determine, how old is your resource, how long is it valid on the browser, and how long are you caching it at the content delivery network. And as we mentioned before, if you're not dealing with a versioned asset, you're definitely going to want to make sure that browser TTL is higher than that browser TTL is lower than the edge TTL. But you also want to make sure that it kind of makes sense with the way that you're publishing the content. So for you as website operators, you'll be able to kind of look at this type of view and just make sense and determine whether or not the TTLs that you're setting at the browser and at the CDN are appropriate. Any question? Mm-hmm.
Could you provide, we kind of went over pretty quickly, for example, version asset, how you would use that?
I'm sorry?
Example of version assets.
Sure. So let's say I was in this case I'm going to take this where is it? Let's go back to. I wonder if this demo logo is. So here's our demo logo, and let's say for example I have a version, and I'm going to just call it V1234. So this here is going to result in a this is going to result in a cache miss on the content delivery network. And now if I request it again, and it's not in the, and let's say it's not in the browser cache because it is at this point, it's going to request it from the CDN, and it's going to be in the cache. So you're going to get a cache hit at the content delivery network. Now, if you've republished your page and now you're saying this should be 1235, well, this is going to be a new resource. And that new resource is going to have a new cache key. So you've essentially published a change to the URL pattern, which instead of having to purge or invalidate your cache, you're just basically starting with new assets that are going to build up cache over time.
And just another example would be, instead of query string, you could even change the file name or the path.
Yep.
So if you go to google.com and look at the URL for the new logo, the actual name of the actual URI pattern has an embedded signature in it.
Do you know where?
It's because there are proxy servers that drop the query string.
Right.
That could be it as well. Yeah. Just do a right click and then.
At one time, most browsers didn't cache anything with a query string. Is that true anymore?
Not in my experience.
Where's the image you were looking for?
Yeah, that one.
This one here.
Yep. So that's the main logo, and if you look at it, it has 2x in the directory structure itself. Can you expand it?
I don't think I can expand that, but I can copy it.
Oh, okay.
So you can see the 2x over here in the.
And also there's some other parameters like the size of the logo. So you can actually change it. It really requires you to instrument your publishing workflow to include these signatures. But essentially, you would, anytime a resource changes, you would change the page that was embedding the resource and include the signature, which could be another file name or a query string, when you publish the link to the resource in the HTML.
So basically, some way of uniqueness within the UI.
Correct. So again, going back to the cache key example, the cache key needs to be unique for the CDN to treat it like a brand new object. Yep.
Are there any, obviously we can roll out our own kind of versioning number scheme or kind of expand our framework. Are there any popular libraries that you recommend or any kind of existing tooling to help to track our versioning across like static assets, dynamic assets, things like that?
Oh.
That's a good question. I guess I'd like to throw out to the rest of the team here. So, are there any popular libraries or tools that you guys use for versioning assets?
I guess a GitHub shop.
I'm sorry?
The GitHub shop.
GitHub shop?
So let's say the JS was stored in the GitHub repo, the latest command.
Okay. So he's saying he uses GitHub.
GitHub?
Anyone else?
Or the shop.
Oh, I'm sorry?
The shop that checks them.
I'm sorry. What?
SHA.
Oh, okay. The GitHub shop checksum.
So if looking for a batch, it'll do it for you automatically. Check some of your stuff. And have the checksum in the web server layer, but most people do it in the build process, like Grunt or Task Grunt or something like that, to what you produce. Same way as if you're swapping a jQuery version. You're not going to change your jQuery version and then just leave the file name the same.
Right.
You change the file name. That's how you download it.
Yep. Right. Any other questions on this? Right. Do you want to flip back to the PowerPoint? Right. So if you guys have used the web page test instance that we had set up before, in terms of like if you look at the cache analysis tab, is there, from your perspective, just kind of what you've learned about right now, do you just a quick show of hands, who here sees like opportunities for optimizing your caching strategy based on what you're seeing in that particular pane? Okay, cool. So at this point now we've got caching configured within the browser, within the cache child, and within the cache parent. So the next step is we're going to look at doing an origin cache. Now if we kind of zoom into the origin, you can see that we've got the CDN parent server here, and that's going to connect to an origin server. But what we've done is we've introduced so this was the origin server that we looked at before that we configured for www.advancedcaching.org. So what we're going to do now is we're going to introduce another server kind of in between the two, which we're going to install Varnish on, and it's going to be our reverse proxy at the origin. So what I've done is I have a very basic Varnish configuration here. So you can see the Varnish, depending on how good your eyesight, I guess, is, you can see the Varnish configuration here is essentially setting, it's listening on port 80. And then the default.bcl is sending the backend request to 54.152.215.217, which was the origin that we had originally set up. I've also created I've also defined a connection timeout of 1 second, a first byte timeout of 5 seconds, and a between bytes timeout of 2 seconds. Now, one of the things with Varnish is that if a request comes in with a cookie header, so any cookie header, it automatically deems it to be non-cacheable. So what we've done here is I've basically taken all of the embedded objects that we're looking to cache here, and I'm just unsetting the HTTP cookie for those particular objects, because we know based on how we've configured this particular instance that actually all of these content types are 100% cacheable. The other thing that I've done here is I've injected a response header that basically indicates whether it was a cache hit or a cache miss. And since we're already using x-cache for the content delivery network, I've called this varnish-x-cache hit and miss. So now that we've introduced a reverse proxy at the origin, the next step would be to route the traffic to the CDN. Now this can be done on the back end, or this can be done via DNS. But in our case, I just modified the CDN configuration here to essentially say, replace the origin server IP with the new origin. I did some testing, so I used I used curl again to do testing, and I can see the x-varnish header. I can see the age of the object, and I can see that it was via varnish proxy, and I can also see that it was a varnish hit. So in this curl command, you probably can't see it in the back, but what I wound up doing was I sent the request directly to varnish, just to verify that everything was working properly. So the next thing I did was I tested this via the content delivery network. So we've configured Varnish, we've configured the content delivery network. So now we believe we have Varnish doing that caching properly. However, the content delivery network is also caching the resources at the edge. So you're not going to be able to. So if you get a cache hit at the edge, or the parent for that matter, you're not going to see the request hit Varnish. That's going to be offloaded from Varnish. And if the request hits Varnish, Varnish is going to offload that request from the origin, and the origin is essentially going to be doing just the work that it needs to do in terms of the dynamic processing. So what I've wound up doing here is I've introduced a cache busting query parameter, and in this case it was just like I added just $X. It doesn't matter what it is as long as it's something that the CDN didn't see. And the idea here is I wanted to get a cache miss on the content delivery network, so I can send the request forward to Varnish. And I can see that I got a miss on the first request, and I got a hit on the second request. So I can see that Varnish is working properly, and then I feel comfortable knowing that I've got my content delivery network in place that is sending requests to Varnish, and then Varnish is offloading that from the origin. So at this point now we've got the browser, the cache parent, the cache child, and Varnish. We've got caching all the way from the browser to the origin. There's still a lot more that we can do here, but at this point I just wanted to stop for questions. Does anybody have any questions? Okay. So the next thing we want to do, and did you want to do the dynamic page caching?
Go ahead.
Okay, so the next thing that I want to talk about is dynamic page caching. So we're gonna look at some strategies to cache some of the dynamic pages, because this EC2 instance that I set up was a really small EC2 instance, and it's probably going to crash under a pretty small amount of load. So there's a couple of different, when you look at dynamic pages, there's a couple of different categories for what's considered what's considered cacheable with a dynamic page. So I'm going to break dynamic page and break that into 4 different categories, where we look at content that's unconditionally cacheable, content that's conditionally cacheable, content that's cacheable with multiple variations, and then content that's truly non-cacheable. So if we take a look at an unconditionally cacheable page, this is just like an image, or this is just like an image or a style sheet. It's essentially an HTML page that's not going to change regardless of who the user is. So in this case, just looking at the About Akamai page, that can be handled like an embedded object. It can just be cached. It can just be cached with a TTL. However, if we look at our page, you can see that we have a shopping cart, we have a login form. We've got a couple of instances where the content could be returned that's different between 2 users. Now, we don't know if it's cacheable or if it's not cacheable. We just know that the visual display is changed. But before we cache that, we want to make sure that it's cacheable. In this case, so we may have a situation where the content is conditionally cacheable in the sense that it can be cached for some users, and then some users you should bypass cache and go forward to the origin. Then you can have a case with like a dynamic page with multiple variations. So, for example, you can have a language option where you want to vary that cache key, but based on a cookie parameter. So in this case, let's say the content changed between the different languages, which it doesn't do on this demo site. But if it did, we could create multiple cache keys based on a custom query, based on a custom parameter that isn't part of the URL. And for a truly non-cacheable page, you just don't cache it. That's going to go forward to the origin, and that's really the safest thing to do. So, quick poll here: does anybody here leverage any kind of caching technique, whether it's at the origin or content delivery network, for dynamic page caching? Great. Does anybody leverage content delivery network for dynamic page caching? Okay, cool. For those of you that don't cache content, that don't cache pages, a quick show of hands, how many people don't do it because your pages are too dynamic? Okay. And how many don't do it because you choose not to? Okay. So the next thing that we want to do here is test the content and see. So for this, let's say we'll take the advancedcaching.org homepage, and we want to see if anything is returned if anything different is returned for 2 identical requests. So what I'm going to do here is, in this case, I'm running 2 different curl requests. If you can't, I'll show this to you in a command prompt in a moment. But there's 2 different curl requests here that are being requested, and I'm just doing a diff between the 2. We should probably switch to the PC view, and I'll just show this interactively. And you can see over here that these are the 2 curl requests. So I've done the curl request in this case because we're already on Akamai at this point. I've done the request direct to origin. So I set a host header string, and then I sent the request direct to origin. And I basically want to see if I make these 2 curl requests and I do a diff between them, what's different that's returned. And in this case, I can see that there's a set cookie. So there's 2 cookies that are set in this. So there's 1 cookie that's set, but it was a different cookie that was set for the 2 different clients. So I have a front end cookie, and this is essentially a session cookie, but we had that discussion before in terms of whether we cache cookies or don't cache cookies. And with the default behavior of not caching cookies, so just removing the set cookies from what we cache, this is content that we feel that we could cache. Now, if we look at something that we know is completely not cacheable, like let's say we do, let's say we do a search. I'm gonna just find who's in here somewhere. Yeah, let's let's say I do a search, and in this case, this is a request where we're doing something for catalog search, shirt versus Akamai. I'm obviously going to receive different content for two different searches. So if I do that, if I run that same command, you can see there's a lot of lines in that diff, and I would expect that because there's completely different content returned. But when we look at the example before, where it's just doing the against the two different requests, where it looks cacheable, this gives me a comfort level that content is really cacheable. Another way that's less command line like that you can do is I use a tool called Charles Proxy. It's a reverse proxy that you run on your laptop that can essentially, like, let's say I go back to the advanced caching page, and I'm going to make a request. And in this case, I'm just going to take a look at the response headers here. Now this is going through Akamai at this point, but I can see this is a TCP hit. I can see I can see actually. So if you see the X cache miss from Rodi, I'm on the Velocity network, and we have a gateway cache here at the Velocity network. So you can see that this was the first time I requested it over here, and I got or maybe it just didn't cache that content because it didn't cache that content because it's max age 0 and private. So I got a cache miss from our gateway cache here at the conference. But it was a cache hit at Akamai because I've already implemented dynamic page caching. But one simple technique I can do is just repeat the cache or repeat the request. So in this case, if I repeat the request, I now have the two different requests, and I can see the request headers here that are essentially identical, and then I can compare the two requests. So I can just highlight both of these and click compare. In this case, I can see what's different about the request and the response, and I can scroll down and just see if there's anything different in the response. And in this case, you can see that the HTML response is completely identical. If I look at the response headers, you can see that the response headers are slightly different. We have a TCP hit from the edge server before, where it's now a TCP mem hit. TCP mem hit just means that it's been requested frequently enough that it's being served directly from memory. You can see that the request IDs and things like that have changed. But for the when we're looking at the body of the response, it's identical. So this is content that can clearly be cached.